Now that we're done with stage 3 and the base system, we're going to move on to configuring the kernel. This is what I would call the meat and potatoes of the Linux system. And the first thing we're going to want to do is this command right here. You don't technically need the firmware. However, if you are running an AMD graphics card and plan on using the AMD GPU driver within the kernel, it's not going to work all that well without this. Now, it's telling me that there are a number of licenses which I need to enable. What do we do about that? I think it was back on the stage 3 one. No, I'm mistaken. It was under the base system. Scrolling further down. This right here. /etc/portage/package.license. Going to make that directory if it does not already exist. And then we're going to cd into that directory. Now, what we need to do is this. Echo sys-kernel/linux-firmware. We do not use the version number in here. It is essentially implied by default. So we need to enable the Linux-fw-redistributable and no-source-code licenses. Those are easy enough to enable. Just do Linux-fw-redistributable type carefully, and no-source-code. Append that to sys-kernel under the /etc/portage/package.license. Now, back to configuring the kernel. There. You see, now it will work. Do we want to emerge these packages? Yes. You have to type out the whole word because otherwise it's just going to assume you mean no. If it has the whole word there, type out the whole word. This is going to take a while to download. It says it's 284 megabytes right there. That's binary megabytes. It's 297 marketing megabytes. And we're operating at a rate of 2.33 megabytes per second or thereabouts. Now, additionally, it mentions microcode. You don't technically need the microcode. I would recommend using the microcode if you are running on a server system. However, it doesn't necessarily need to be done. After this, it will tell us to install Gentoo sources. At this point, I have to wonder if it's got the 6.0 kernel and stable yet. I suppose we'll find out. Or I could just not wait at all and do this number. Packages.gentoo.org gives you a good overview of the entire portage repo, showing you every single package that is available in the official repository, to include Gentoo sources. And apparently there is no stable version of the 6-point kernel on Gentoo as of yet. The latest one we'll be able to install is 5.15.80, unless we override the keywords. So what the system is going to do when we say emerge ask syskernel gentoo sources, it's going to pull this one right here, because it's the only one with green on it, and we don't have tilde AMD64 set. So emerge Gentoo -sources. You'll note I didn't even use ask, nor did I use syskernel. It can run the merge even if it's not technically the full package name, and you don't need to use ask either if you know what you're doing. And frankly, I think I know what I'm doing here, to a certain extent. It's going to take a while for this thing to actually completely install, because it has a number of dependencies to install. Once it does install the sources, we need to select the kernel that we want to set as the default kernel. This will basically set up a symlink at /usr/src/linux, and it'll point that symlink to whichever kernel I select, which in this case will be, what did I say it was again, 5.15.80. Somewhere down the line, I'm probably going to end up selecting a 6.2 or something kernel from the 6 series. After this, it asks us to emerge PCI utils, and I would recommend, parallel to that, also getting USB utils. This will give you the commands lspci and lsusb. What do these do? Well, they basically allow you to probe for devices on the PCI and USB buses. And if you know what those devices are, you can simply go into the kernel configuration and enable only what you need. And this thing gives you the kernel configuration options. It handles them in a bit of a wacky order. Honestly, I don't understand the logic behind the order in which it goes. But that is, of course, neither here nor there. We shall emerge PCI utils and USB utils. And apparently that's going to be 6 more packages that we need. Inside the chroot, it is safe to ignore any PCI lib warnings. I should also mention at this point that the chroot is going to be the environment that we're installing. You see, this system right here is the live CD. When we ran the chroot command, it basically changed the root directory to /mnt/gentoo. Thus, as a result, we have this. And when we run the system proper, it will be mounted in the / directory. That would be called root. Now, we have all this. Let's do a real quick lspci and then an lsusb. Make sure I don't have anything super fun plugged in. I have no idea what that is, the Hitachi one right there. Not a clue what that is. However, we don't have much as far as devices. We have a Logitech unifying receiver, which is for the mouse that I'm using. We have an Intel Core Bluetooth wireless interface. The PCI ones are the ones that we need to be more concerned about. There's a lot of those. And if I'm not mistaken, we can do that within the actual live GUI environment and get the same results. So we don't technically need to install PCI utils or USB utils, but these are going to be useful down the line, especially if you end up changing your hardware at any point. For example, if you end up changing your graphics card or adding a new network card, things of that nature, those will definitely come into play, and you will need LSPCI and or LSUSB. Now, how did I know it was set 1? Well, I only have one kernel installed. That's how I know. Now, cd/usr/src/linux. I should also note that eSelect in this case doesn't just, it doesn't do anything particularly special. All it really does is it creates the symlink to get to the kernel. So for example, let's do ls-l ... You see what it does is by default this symlink right here does not exist. What this thing does is it creates this symlink. Also, if you at a later date decide to update your Linux kernel, let's say Gentoo finally puts into place a 6.0 kernel, all this does is it retargets the symlink. So, if you want theory, here we go. Yeah, that's the one. There. Now, we don't have a symlink set, and eSelect kernel list shows no symlink set. If we want to manually set the symlink, we just do this. ln-s Linux 5.15.80 Linux. And there we go. The symlink is in place. We placed it there manually. And eSelect kernel list is happy as well. So most of the stuff that eSelect does can be done manually. Now that all of that is out of the way, let us get into configuring the kernel proper. Make menu config. Now, as I've said, this thing goes all over the place. So the first few options we're going to need to check are down here under Gentoo Linux. And those are Gentoo Linux support, Linux dynamic and persistent device naming, and select options required by portage features. Looks like all of those are set. Support for init systems. If you're running systemd, you should enable this and disable this. However, we're running OpenRC, so we'll keep this enabled. And that looks like all we need to do. So we'll go back. We need to go down to device drivers, generic driver options, maintain dev tempfs at dev, and auto mount dev tempfs at dev. Generic driver options, maintain dev tempfs, auto mount dev tempfs. That one looks good. Enabling SCSI disk support. This is going to be necessary for any hard drive or optical drive that you use. Also, if you happen to use a SCSI tape drive, you should probably enable that, maybe. That aside, it does not look like there is much that I need to be worried about. We have SCSI disk support, SCSI CD-ROM, and SCSI generic support. It tells you to just enable SCSI disk support, but if you happen to have a CD-ROM or other optical drive, you should enable that here, or at least ensure that it is enabled. We're going to move down to File Systems, which is down here. You're going to need to select all of the relevant file systems which you will be using. In my case, I will be using ext4, and down here, I'll be using MS-DOS and VFAT Win95. If you want read-only or read-write access to NTFS, you can enable that here. If you want exFAT file system support, you can enable that here as well. We want UDF right here so that we can read and write DVDs. We have Fuse right here, which is file system and user space. I'm not going to enable that at this time because it just makes for a whole bunch of complications. Network file systems. This is for if you have network file systems such as file shares from Windows, so on and so forth, or if you have network attached storage on your local network, you might want to enable these. Or at the very least, just not disable them. It looks like we have everything we need here. And right here it says selecting PPPoE necessary drivers. As it says, if PPPoE is used to connect to the internet or a dial-up modem, then enable the following options. I'm not using PPPoE to connect to the internet, nor am I using a dial-up modem. If these options are enabled by default, I'll keep them enabled, but I am not going to worry about them otherwise, because I do not use these options. We're going to move down to SMP support. This is for symmetric multiprocessing. What this is if you have a system with, Intel calls it hyper-threading, you would want to ensure that that is enabled. It's under processor type and features. I was on the wrong one. Symmetric multiprocessing support. Activating USB support for input devices. That is, again, back down under device drivers, and it would be under HID support. HID. USB HID. It looks like everything's enabled. HID bus support, generic HID driver, battery level reporting. Why not? And USB HID support, USB HID transport layer should be enabled. It is apparently enabled by default. We will then want to go down to USB support. If you have USB 3.0 or any of its subsequent USB standards on your system, you'll want to enable this option right here. If you do not have USB 3.0, you can disable this option to save a little bit on kernel space. But it would appear that we have everything that we need here. Except I want this right here. Because I use one of these devices right here to connect to my Raspberry Pis if I need a serial interface. I also use it to connect to my Synology NAS if I need low-level interface to that. There's also USB Type-C support, however my motherboard does not support USB Type-C, at least not directly. That's all that we need to do for there. Let's go back up to processor type and features. Like I said, this thing jumps all over the place. Machine check overheating and reporting. If I can find where that is. We want to disable the AMD MCE features and enable the Intel features. Obviously, if you are using an AMD CPU, you will want to enable AMD and disable Intel. This is a simple space-saving matter. You can have them both enabled if you want. I cannot particularly recommend that, though. Now, given that we are using an Intel CPU that is not an Intel Atom, nor is it a Pentium 4 or older NetBurst-based Xeon processor, we need to use this option right here for processor optimization. Additionally, binary emulations, I believe that's near the bottom of this. No, it's in a different category, excuse me. Oh, there it is. Need to ensure that IA32 emulation is enabled. Don't enable this right here. It's just going to throw you nasty grams, and honestly, it was experimental to begin with. There's really no need to put that in. Next up is the block layer, which should be enabled by default. This allows you to access hard drives, SSDs, USB drives, everything of that sort. You want to go to Advanced Partition Selection, ensure that PC BIOS and EFI GUID partition support are both enabled. If you happen to use some other operating system that you want this thing to be intercompatible with, you could enable that here. So for example, if you're using FreeBSD or something like that, you can set that up right here. Otherwise, just EFI GUID partition table and PC BIOS will be fine to enable. Now, support for UEFI. Under processor type and features, it tells us to use EFI runtime, EFI stub, and EFI mixed mode. believe those are closer to the bottom. Yes, here they are. EFI, runtime, stub, and mixed mode. So those are all enabled. That is good. Now we go to device drivers. Firmware drivers EFI. Firmware drivers EFI. And it tells us to enable EFI variable support via sysfs. It would appear that that's already enabled, so we don't need to change anything there. And after that, we need to go down to graphics support and frame buffer devices. Graphics support. Frame buffer devices, support for frame buffer devices, enable. Leave everything as is, except enable support for frame buffer, well, obviously we just enabled support for frame buffer devices. Leave everything else as is, but enable EFI-based frame buffer support if it is not already enabled. You can leave these two as they are. Go back again. And on this one, you'll need to take into account what graphics card you have. As you can see here, we have, where is it? Ah, there it is. VGA compatible controller. Navi 23, Radeon 6600. Yeah, I know it's not special. In fact, it's a pretty low-end card, but it works for my purposes. So, that is the only graphics card I have in the system. Since it is the only graphics card I have in the system, I can simply disable Intel Integrated Graphics and enable AMD GPU. Want audio coprocessor support, and we want everything. I don't think we need HSA kernel driver. What is that anyways? Well, that tells me absolutely nothing. I believe that is all we need as far as graphics drivers go. We're going to exit at this point, and we're going to go down to sound card support, ALSA, and we are going to ensure first off that HD audio for HDMI DisplayPort audio codec is enabled, and I'm going to see if there is an option for the Intel sound that is enabled. We've got audio device, Intel Corporation, HD audio controller. So we need this enabled, and we need to find something that is compatible with the Intel HD driver. Here's what I'm going to do. Sound HDA codec generic, Sound HDA codec Realtek. HDMI, HWDEP, Sound HDA, Intel. That's the one we need. So, let's see if we can find that one. That'd be under HDA. And I am not seeing anything for Intel. Oh. Config Sound HDA Intel. Okay. We're going to go ahead and build the rest of these as modules. After all, we want the HDMI device built as the default, so we want it to load before anything else. By setting everything else as a module, you ensure that those load after the first device. I'm going to set up USB sound devices as well because I happen to have a real tone cable which came with my copy of Ubisoft Rocksmith. It's actually a pretty fun device to have. So I can record my bass guitar onto my PC. It's just a fantastic option to have. So now we do make && make modules underscore install && make install. Make -J8 && make modules install && make install. So run everything all at once. It's going to take a while for the kernel to finish, so I'm going to do a jump cut right here and get back to you at the end of this particular process. And there's the jump cut. We got the kernel installed and all of its modules. We're not going to bother with building an init ramfs because the way the system is structured, we don't actually need an init ramfs. The kernel installation process gives you a few different options as well as far as making a kernel. A number of the people I've seen on YouTube building a kernel with Gentoo will decide to use either a distribution kernel or gen kernel, as shown right here. Those are valid options. However, the best option is to actually use the kernel sources themselves and configure them yourself. After this, it tells you to configure the kernel modules. You don't technically need to do this. However, if you want modules to load in a specific order, you can do that using modules load.d. And all of that's explained right here. Otherwise, the system, as it detects different devices being connected, will load up the necessary modules. However, once the devices are disconnected from the system, the modules will not automatically unload. So if you, for example, have a USB device which requires a special module, it will automatically load that module, but once you're done with that USB device and you disconnect it, it will not unload the module. You have to do that manually. In any case, it would appear that everything is complete here, but what we are going to check, just to make sure, it would appear that the kernel has been sent to the /boot directory, which is good. After this, the next part will be configuring the system, and after that, we have installing tools, configuring the bootloader, and finalizing. That'll be all for this segment. I hope you tune in for the next one.